Hello class, Mr. McHugh here with you kicking off section 8.3, simplifying radical expressions. I'm going to take care of page 1 here, and hopefully you've been noticing I've been trying to, they like to call them rules or shortcuts. I've been trying to label these just with letters so you can help be organized here. Make a suggestion that perhaps you keep a reference sheet list of these in here. Put them in your own words so you can memorize them. This is to help you learn it. I don't expect you to be using this on the test, just that it's a good way to get them in your brain so you feel comfortable with them. And hopefully you're using the words that I've been suggesting here to you and not trying to memorize the lawyerese writing. Okay, so this rule is called the product rule with radicals here, and so here's the story. What happens if you have to multiply two radicals? Radicals, you've got the symbols, they got to have the same base. Could you possibly be allowed to multiply underneath the radicals, the radicands? So 36 times 4 is 144. If you took the square root of 144, you get 12. Okay, is that legal to do that? That's what the rule is proposing. Well, I like to give these informal proofs by simply saying, what's the square root of 36? 6. What's the square root of 4? 2. 6 times 2 is 12, and boom, you've just had an informal proof of the product rule for radicals. Okay, so what that's saying is when you have the same index, you're taking the same square root, cube root, fourth root. If you're multiplying two radicals with the same index, multiply the radicands and you'd simplify. Okay, so a couple easy examples here. Square root of 5 times the square root of 7, square root of 35. You can't simplify that anymore. Over here, square root of 7 times the square root of 11x, y, z. Just multiply 11 times 7. Keep it all underneath the radical sign and you're on your way. Okay, so this is a warm-up section here. It's not too bad. How about example 2, some more product rules. You're multiplying now. Do you have the same index? Yes. So 3 times 12 is 36. You're taking a cube root of 36. Okay, and that's all you can do on that one. Over here you've got the same index, you're taking the 6th root, so multiply the radicands. So 10 times 5 is 50, m to the 4th, m to the 1st, add them up, m to the 5th, and you're on your way. Now how about look at example D. Watch and be careful. Index 4, index 5, can you multiply them? No, you have to leave them alone. Think of them as like different terms. You cannot combine different terms. So you're not combining, in this case you're multiplying. So it's just trying to get the idea in your head. Okay, objective 2 here, we're going to talk about the quotient rule for radicals, and we've kind of done this before, but the idea is this. If you have got the square root and you got a fraction underneath it, what times what gives you 9/4? Now I'm trying to prove to you here that 3 halves times 3 halves is 9/4. So what times itself gives you 9/4? The answer is 3 halves. Okay, so the rule is now, can you separate the numerator and the denominator and still keep the radical signs on them? So take the square root of 9 divided by the square root of 4 and you get 3 divided by 2. Square root of 4 is 2, square root of 9 is 3, and yes, you can do that. Okay, so there you go. That's quotient rule. It's letter G on my list here, working our way down, and it just says when you have when you take in the radical of a fraction, you could separate it into the numerator or denominator, and again with the same base. Same index number there. A couple examples. Square root of 16 the square root of 16 25ths is equal to the square root of 16 divided by the square root of 5. Evaluate the two square roots, you get 4/5, and you're on your way. Over here, this guy, break it down into the 5th root of x divided by the 5th root of 32. What number multiplied by itself 5 times gives you 32? Answer 2, and the 5th root of 5 you leave alone. Okay, so there you go. A fairly easy section to get us going on page 1. So Mr. McHugh, going to wrap it up here, and I will see you for page 2, and we'll tackle more of these problems here. Okay, bye bye.